A total solar eclipse is the most spectacular natural phenomenon you can see on this planet. It's really that good. If you think the Grand Canyon, Niagara Falls, Banff, or the fjords of Norway are spectacular, you're right. But this beats them all. In fact, it's so good that even though I just hyped it so much, you'll still be impressed. But no photograph of it looks much like it at all. So instead, I'll start by showing you a short clip of how people react to it that I recorded at my last eclipse. I'm Brad Templeton, and while this channel is mostly about the future of transportation, I've seen 6 total eclipses, which is enough that I can give you some good advice on how to see one, in particular the one that crosses North America in April of 2024. I've also gotten some skill at photographing them, which will let me advise you on why you should never, ever try to photograph during the total phase, no matter how good you are at photography, and how you can come away with some good images nonetheless. Get ready to be followed by a moon shadow. Yes, I'm being followed by a moon shadow. The first thing you need to decide is where you're going to be to see the eclipse. You absolutely must be within the zone of totality. If you are outside, you will see a partial eclipse. Those are fun, but something else entirely. The difference between seeing a partial eclipse and a total eclipse is like seeing a grand jury or the Grand Canyon, like Tom Cruise or an Alaska cruise. While a total eclipse includes everything of a 99% partial eclipse, it's really something else entirely. The difference is literally and metaphorically night and day. That means that you need to pull out a good eclipse map and find a spot that is in the zone of totality by at least 1/3 of the way toward the center line, if not more. Many aim to be right in the middle, and you get the longest eclipse there, but it's perfectly fine and only loses a few seconds to be a few miles away. I recommend you use an interactive map that shows the eclipse on Google Maps, and you can find one linked in the description. You can click on spots and see how long the eclipse will be there, as well as all the times. Some people actually find virtue being a bit closer to the edge. You get more edge effects, but it costs you time. For your first eclipse, I recommend you make it last the full 4 minutes or more by being near the center. Here's what the map looks like. When you load up an eclipse map, you'll see Google Maps with lines across it showing the path of the eclipse. So you zoom in to find the location that you're thinking of looking at the eclipse, and all you have to do is click on it. Then you'll see all the parameters of the eclipse at that location, including, most importantly, how long it's going to last, right at the top, total solar eclipse it has to say, and also what time each of the points of contact in the eclipse will take place, how high the sun will be, what direction it will be. All of that will be there, and you can click different locations and see. Now, for example, if you look at San Antonio, Texas, you notice that there's no eclipse on the southern side of the city, and if you are in the northern side of the city, you'll see the eclipse, but only for 1 minute and 36 seconds. Among the large cities, don't stay in San Antonio, Austin, or Northwest Dallas. Louisville, Columbus, Cincinnati, Toronto, and St. John's get nothing, and places like Montreal, Hamilton, and Toledo get something very short. You don't want to stay there. If you are 500 miles away, we might understand you not being able to make the trek. But if you're in one of these edge cities, it's a horrible shame if you can't make the short, though crowded, journey deeper into the path. Around the larger cities like Austin, Toronto, and Montreal, this will mean huge traffic. The first thing you'll want is clear skies. Right now, the best you can do is look at the average cloud cover for your site. The best chances for that are in Mexico, particularly from Mazatlan to Torreon, but for those staying in the USA, Texas is definitely the winner, and it gets worse as the path moves northeast from there. At this late date, most hotel rooms in the path of totality are booked, and flights are costly. While it's definitely preferred to stay at your observing site, don't be discouraged if you have to drive a bit. You can save a lot of money staying at or flying to just outside the path. Just make sure there's a big road to get you in. Observing sites will get crowded, and the police may close roads, forbid parking, and direct traffic. As eclipse day approaches, though, you can start looking at real forecasts, which might be very different from those averages. If your area has a poor forecast for clouds, consider moving, perhaps a long way. The bad news, of course, is that forecasts can be wrong, and there will be many other people also chasing the clear skies. You may want to pick a site that's near a major highway so you have the ability to move. Even though you might have paid a lot for a hotel, be ready to toss it aside when you see the real weather. People actually are impressed by eclipses behind clouds, so it's not a total loss. But don't forget, Grand Jury versus Grand Canyon. Your main goal is to just watch, especially the total part. Many people don't realize that you watch the total part with your naked eyes, or perhaps binoculars. You don't wear any eye protection at totality. All those warnings and eclipse glasses you will see are only for the partial phases. During the partial phase, you definitely need them. Staring at the naked sun is, of course, dangerous, but we all normally know that and don't do it. The eclipse makes some people disobey that instinct because it's different and interesting, so you just have to make sure you know that and avoid the temptation. Children who are well instructed and watched by their parents should not be hidden inside. Just let them know when it's safe to look. You'll spend the 3 to 4 minutes of totality staring up at the eclipsed sun in awe, and a small bit of time observing your unusual surroundings. You'll probably just be standing up, though you could be on a reclining chair. This eclipse will be high up if you're west of Toronto. Binoculars are also great, so watching it is very simple. It's about as bright as the full moon in a suddenly darkened sky. The start and end are particularly spectacular, but need a bit more care, which I'll talk about in a bit. As I outline what you will see, I will show you some photos and video snippets from my observations of the 2017 eclipse, which also crossed the USA. In a schoolyard in Oregon, I was with family and a crowd of about 100 strangers. For most of the eclipse, the most obvious things will be what are known as the corona and prominences. The corona is the sun's huge atmosphere, which stretches out for millions of miles and is full of delicate streamers. The prominences are red arcs of fire, many times larger than the Earth, reaching out from the edge of the sun. You'll see them with your naked eyes, but binoculars will do a great job to see the details. Most obvious in many ways, though, will be the impossibly black hole in the sky where the moon is covering the sun. You have never seen anything so dark or black before. Just understand that no picture of an eclipse really looks like it does in real life. There are a lot of things that are difficult to photograph well, but nothing is harder than an eclipse because there's a greater range of brightness than anything else in nature. Only the human eye can capture that range. It's okay to spend a little time not looking at the eclipse. Your setting will become surreal. All around you, you will see a 360-degree sunset because the sun has set only right where you are. A few stars will come out, as will the close planets. This time, all the visible planets will be close to the sun, with Mercury and Jupiter to one side and Venus, Saturn, and Mars to the other. That's worth checking out. You will also notice that some of the bright stars, being early April, the sun is in Pisces. The astrologers are confused about that. Orion and a few others, they will be visible, but you can see them anytime, so don't spend too much on it. You might also have noticed this during the partial phase, but animals will be reacting to the surprise and sudden night around you. The best place to watch is with a group of people. An organized group will often have an eclipse guide on a loudspeaker who will be telling you what to watch for and, most importantly, when to watch. As I said, you can't look at the partial phases without protection, but the most spectacular part of the eclipse is the transitions, what we call second and third contact, where you see something known as the diamond ring. The first diamond ring is the very last bit of the sun disappearing just before the moon covers it up. The reverse happens when the first bit of sun is revealed. It's okay to look at this small speck of sun for a very short time without protection, and it's amazing. The challenge is to know when to remove your eye protection and watch. With your eye protection on, you will see the small sliver of sun that will vanish, and then you could take it off, but you may have missed the diamond ring. To help, I recommend you have an eclipse timing app on your phone, or be with an eclipse guide who is calling things out. This app will know the exact time and your exact location, and it will tell you when the diamond ring begins, just a few seconds before totality. It's okay to watch the last 5 seconds of diamond ring before and after totality. Now, because of caution, many people miss that first diamond ring, and if you're a beginner on your own, you might be afraid to try. The good news is that it's much easier to watch the second diamond ring at the end of totality, the event known as third contact. I'll skip ahead to that end at third contact first. While you're watching the total eclipse, you'll start to see the signs it's ending. One side of the black circle will get a bit brighter, and eventually a red arc will appear, which is known as the chromosphere, or inner atmosphere of the sun. You will see more prominences appear on that side as the moon slowly uncovers them. You always see the most prominences and other phenomena right at the start and end of totality. Then, suddenly, it will happen. A tiny piece of the sun's surface will peek out of a valley on the edge of the moon. It will be tiny, but so bright compared to the corona that it's overwhelming and amazing. And it will start to grow and get brighter. You'll immediately see why people compare it to a diamond ring. You can and should watch this for around 5 seconds, and then you must look away. If you want, you can pull out your eye protection and see a few of the partial phase features, but frankly, you're going to be in an enhanced emotional state and mostly just wanting to soak it in. Other than the few seconds of the diamond ring, spend no time looking at the sun outside of totality with your unprotected eyes. If you see it in a crowd, it's also as exciting as a spectator sport. There will be cheering and happy noise all around. In reality, people do most of their observing before totality, and after that, the partial phases are so modest in comparison that most folks pack up or socialize and barely watch all the way to the end of the partial eclipse, what we call fourth contact. After third contact is also a good time to look for any of the 99.9% partial effects that you may have missed in your excitement at second contact, such as the beads, the shadow bands, and the retreating shadow of the moon. Of these, the shadow is the most dramatic. While I wish you clear skies, if clouds come to you and you couldn't move out of their way, you'll still get a dramatic show of sudden night in the middle of the day. You may also see glimpses of the eclipse if the clouds are thin, so keep up hope. My fifth eclipse, it was only clear for 20 seconds, but most people present still felt totally amazed. There are various apps for mobile phones and laptops that will time the eclipse for you. Most of them will let you simulate what they will do when you are at your planned eclipse site, as totality is happening. I recommend you try that simulation so you'll know what will happen and to make sure you like the app and know how it works. You'll want one that lets you do this in simulation, but on eclipse day switches to using the exact GPS location and network time. You'll want one that speaks a countdown to second and third contact out loud, so you don't need to look at the phone. Some will give you alerts about mid-eclipse. It will surprise you how soon this comes, and the time to look for things like shadow bands and Bailey's beads, but in particular the diamond ring. Some of these apps, like Eclipse Droid, which is free, can also control cameras, but you won't be taking photos. Another app, named Solar Eclipse Timer, will give you the audio callouts. It has a small in-app purchase to work for this eclipse. There are also apps for Windows and Apple laptops which do audio, though they have the most focus on photography. I use Eclipse Orchestrator, whose free version will announce things for you. If you recommend any Apple apps, please note that in the comments. Going back in time, I took you through totality because it's the most important part. But while partial eclipses are modest in comparison, they're still interesting. Indeed, they also provide an emotional build-up to the main event. Usually the partial eclipse starts a bit over an hour before totality at what is called first contact. The app on your phone will announce it, and very shortly after, you will see a tiny notch taken out of the sun. What's exciting is now you will feel it is real. You can watch the partial phases through eclipse glasses or other suitable protection like a number 14 welding glass. Another good way is by having a moderately experienced astronomer project an image of the sun with their telescope. They point the telescope at the sun and then send the light onto a projection screen, any flat white surface, for all to look at safely. There are some dangers, which is why this telescope owner has to have some experience doing this. One must absolutely never look into the eyepiece, as that can be very quick eye damage, and you need to make sure that random people passing by don't look. If you don't cap it, the finder telescope on most telescopes will also focus the sun in a way that might cause trouble. Things can actually get quite hot. After finding the sun, it should get a lens cap over the front. One very handy feature of a projection setup like this is that people can pose with it for photographs. It's really one of the key ways to make a souvenir photo of people at an eclipse. Even better is a telescope with a special solar filter over the end. A quality filter will produce an excellent image of the partially eclipsed sun, and you'll see sunspots and other details on it, and even a bit of roughness to the edge of the moon. It is also possible during totality to remove that filter and look at the eclipse through your telescope, and it's very cool, but for most people, the eyes and binoculars are all you need. As the moon's disk gets larger, you will see a crescent. Then you'll notice that any pinhole becomes a projector of the sun's partial image. You can poke a hole in some paper and make an image on anything, including your clothes, which can make another good picture. I've even poked pinholes to write out the year, for example, for a souvenir photo. Best of all is to look below trees, where the leaves make hundreds of pinholes. The shadow of some trees will be a sea of waving crescents. The bad news is that most trees don't have too many leaves on April 8th, depending on where you are. Excitement will build as you get close to totality. If you've ever watched a pure partial eclipse, a lot of folks did last December, you will see that unlike then, the moon is dead center, and it's going to eventually eat the sun. You will see the character of the light change. All your life, the sun has been a disk, and the shadows have soft edges. Now it's a thin line, and the shadows are all super sharp. Everything looks different. And to the southwest, the direction the moon is coming from, you will see the sky get darker as the shadow is covering the land off in that direction. It only gets really obvious just a few minutes before totality. Some people go to hilltops to get a better view of this. Animals will start to notice. You might see some starting to bed down for the night. That's one of the extras you get to see with an eclipse on land. I've also watched on a ship where you don't get that. Some watch from an airplane and they miss all of this, but they get some other advantages that make me want to try it someday. Many eclipses, in fact, can only be seen from aircraft. Right before the first diamond ring, there are a few things that you can watch out for. They aren't very spectacular, so don't let them distract you too much from the main event. The first is called shadow bands. If you have a white surface on the ground, as you might from laying on a bedsheet, you may see little wavy lines wiggling, a bit like the sunlight on the bottom of a pool. The thin crescent sun is acting more like a point source of light. You can look for these, or instead look at the approaching shadow from about 120 to 30 seconds before totality. The last is called Bailey's beads. Just before the end of the moon's rough edge, with mountains and valleys, lines up with the edge of the sun. What was a super thin line now becomes a series of dots at the edges as light goes through the valleys of the moon. Eventually, it will reduce to one spot, the diamond ring. On the other hand, some folks at this time close their eyes or wear dark goggles to adapt their eyes to the darkness to come. I've wanted to do this myself, even have the goggles, but somehow I've never gotten around to it. There's too much other excitement. People are so tempted to photograph it. It's the most amazing thing they've seen. It doesn't work. You won't believe me, and I see people pull out their cell phones or other cameras even when they've been told this. Try not to. Even experienced eclipse photographers like myself do not photograph it. Instead, we watch it while our computers do the photography. For us, we set up in advance and have a computer do all the timing and shooting. That's what experts do. If you're not that sort of expert, do not, I repeat, do not, under any circumstances, waste precious time photographing the total phase. On the other hand, you can photograph the people you were with all around you. In fact, making a video of your group or the crowd is a great idea. In this case, though, set up your camera or phone on a tripod and start the video a few minutes before totality and let it run. And set up more than one. Maybe shoot a time lapse of the group for the full 2.5 hours. Shoot images and selfies with the projected partial sun, the pinhole crescents. Don't try to photograph yourself with the eclipse. It's really not going to work. The eclipse will look like a badly exposed blob in any conventional photo. If you're a very experienced photographer, I have a link to a talk I gave about what you can do, but my advice is the same for even the most serious photographers on your first and second eclipse. Just watch it. I didn't take a tolerable photo until my third eclipse, and I regret the time I spent on that. For your videos, if you have multiple cameras and phones, you can take a few of the crowd. Consider one in a fixed exposure that will really show how dark it gets, since auto exposure videos will actually adjust and hide that. If you have a wide angle, you can include the sun. Unlike your eyes, your phone has a small lens and its camera, and it won't be burned out by seeing the sun for a bit. In addition, if you're having a computer photograph things, you'll need to manually take the filters off. You can do that about 30 seconds in advance, unlike the filters for your eyes, which don't come off until about 2 to 5 seconds before totality. That way, playing with the filters won't distract you from the main event. You might want to watch my edited 4-camera video of the 2017 eclipse. In it, you'll see photos and video of the eclipse mixed in, those were taken by the computer, with the video and audio of the group from in front and behind. Watch us see the shadow coming behind us, rush to take the filters for automated photography, and then just watch. Start at about 4 minutes and 15 seconds if you don't want to see the advanced part. Many people who see an eclipse immediately want to see the next one. The bad news is there won't be another in the United States and Canada for some time. Barrow, Alaska will have one in 2033, but otherwise you'll wait for a pair in 2044 and 2045, which will be in easier to reach places. What that really means is you need to go overseas. Many people do. There's a whole industry of eclipse tourism, and people chase eclipses because the eclipses are spectacular and they take them to interesting places in the world. Almost every eclipse has cruise ships which sail to its path, a very luxurious approach, which I did for my second or third eclipse. August of 2026, we'll see totality in Spain and Iceland, and remote parts of Greenland, and Russia if you want to go really far. It's at sunset in Spain, which brings high risk of clouds, but just as the moon looks more dramatic as it rises and sets, should be spectacular. In 2027, you can go to Africa and to Australia in 2028. Maybe I'll see you there. Thanks for watching, and come back here a bit after the eclipse for my video of it, and later for different content on self-driving cars, electric cars, and the future of transportation, which is what I do when I'm not chasing eclipses. Clear skies.